All right, so far in this module, we've been looking at quadratic functions, and we've been talking about them in terms of the real number system. And in terms of all your math classes so far, that's probably all that you are aware of. But when we talk about mathematicians, the history of mathematics, mathematicians don't like being told you're not allowed to do that. For instance, they don't like being told you can't take square roots of non-perfect squares. They don't like being told that you can't take the square roots of negatives. The only one they haven't been able to fix is dividing by 0. But every other time they invent new number systems. And so let's go ahead and review that. If you recall, at the beginning of the semester, we talked about different number systems. We talked about the natural numbers, the whole numbers, the integers, and the rational numbers. Well, as I mentioned, many years ago, centuries ago, in fact, it was considered really taboo to do things like square root of 2. That was something that was not allowed. And then, of course, someone said, well, why not? And so they went ahead and invented something called irrational numbers. And so irrational numbers, these are the ones that we saw previously that were not nice. Square root of 2, pi, e. We'll talk about e later this semester. And remember that irrational numbers, this is when, if you write it in decimal form, it is a non-terminating, non-repeating decimal. It goes on forever, and it has no pattern to it. And when we combine the real numbers and the irrational numbers, we get something called the real numbers. Now, in the real number system, not everything is allowed. We do still have one thing in particular that we're not allowed to do, and we kind of just pass it off and we just say it's not real or it's undefined. And that is square roots of negative numbers. Well, again, mathematicians don't like this, and so they go ahead and say, well, let's go ahead and invent a new number system. And so instead, a number that is not real, we call it imaginary. And our imaginary unit, we're going to use the letter I. And what this is equal to is the square root of -1. In order to get an imaginary number into the real number system, if we square I, this is equal to -1. The square and the square root cancel. This is our imaginary unit. We also have imaginary numbers. Imaginary numbers is a number that can be written as b times I, where b is a real number. So 5i, 7i, I square root of 7. Okay, this is... as long as the number part is real, then, well, it's considered an imaginary number. Sometimes we refer to these as pure imaginary numbers because there's nothing else involved in it. It's just an imaginary number. So when we look at the real numbers, we are combining rational and irrational. And so when we get to the complex numbers is going to be a combination of real numbers and imaginary numbers. They are written in the form a plus bi. And so all of the numbers that we've been talking about so far, they're still valid. They still exist in the complex number system. Notice here that it doesn't say, it just says A and B are real numbers. They can be zeros. So for instance, b can be 0 and we get a. It's still a complex number. It's more specifically a real number. We can let a be 0 and we get just bi. And we can call this an imaginary number. And so when we combine these two things together, we get the complex number system. All right, so the main thing that we want to keep in mind in this section and moving forward is, remember previously when we took square roots of negatives, we either identified them as undefined or not real. From here on out, we do acknowledge their existence and we refer to them as complex numbers. All right, so the first thing that we're going to do when we talk about complex numbers is we're just going to play around with them a little bit. Because these are negative square roots, we're going to talk about, okay, how do we simplify them? The first thing is it's going to be very similar to what we did previously. We want to simplify the number part of the square root if possible. Remember, we can either take the square root if it's a perfect square. We can separate it into squares and non-squares if it's not. And so it's going to be the same thing. The main thing that we are going to do differently is if we have a negative inside the square root, we're going to pull it out as an I. We do need to be very careful when we are working in the complex number system. If you recall, when we worked in the real number system, if we had square root of a times square root of b, we could combine that into a single square root. But we do run into a problem because this is not true when both a and b are negative. If you have a and b are negatives, then what we have to do is what we talked about in the above step. We want to bring the negatives out as i's and multiply them. We're going to get I times I. And remember the rule that I squared equals -1. Another thing that we can do, and this isn't a high priority topic, this is kind of just for fun, is that we can go ahead, there is cycles of I. And so we can raise I to any power and we're going to get one of 4 possibilities. Let's start with I. All right, if we start with I, well, it's just equal to I. Remember that when we square I, we get -1. I cubed is equal to -I. And so let's talk about why is that. Well, I cubed is equal to I squared times I. We have I squared is -1. And so what we get is -1 times I, or just minus I. Similarly, for I to the 4th, we can rewrite this as I squared times I squared. And this is equal to -1 times -1, which is equal to 1. After that, it repeats. I to the 5th is I to the 4th times I, which is 1 times I. I to the 6th is I to the 4th times I squared. I to the 4th is 1, I squared is -1. And so we just have this constant repetition, this constant period of i's in periods of 4. Okay, let's go ahead and try some examples now. All right, so the first round of examples that we are going to look at, we are going to see the square roots running around. Okay, and so we are going to practice taking these negatives out of the square root and moving them to the front as an I. All All right, so let's look at the first three. We have A, B, and C. All right, for example A, I'm going to start by looking at the number. I always like starting with the previous stuff first. And so I'm going to ignore the negative for now. And I just want to know, okay, what is the square root of 16? Well, the square root of 16 is 4. And now what I want to do is I am going to take out the negative. And the negative just becomes I. And you're done. That's all we have to do. For example B, we have the square root of -3. And I can't take the square root of -3. It is not a perfect square. It doesn't contain any perfect squares. And so what we do with it is we leave it inside. Now, I still have to deal with the negative. And so I just bring the negative outside as an I. And we like to put it in front of the square root. That way there is no confusion about whether it's inside or outside of the square root. All right, for example C, we're going to have to do more work on this one. Okay, so 60 is not a perfect square, but it does contain a perfect square. And so we do want to factor it. The factors that we want to work with, we don't want to go with 2 and 30. Neither are squares. 3 and 20. Neither of those are squares. But 4 and 15, this is the one that I want to work with. We can take the square root of 4. That is equal to 2. So I'm going to put that in front. And I'm going to put my 15 inside the square root. It doesn't simplify any further. 15 is 3 times 5, no squares there. And then finally we have the last thing that we want is we want to take care of the negative. And again, we're going to pull it out. And just like when we write just square simplified roots in the real number system, same thing when we add in the complex numbers. We like everything in front of the square root. So we're going to write this as 2i square root of 15. All right, the second set of examples, we're going to look at putting this in a larger context. And so, for instance, where are some examples where we're going to run into negatives? Well, we run into them when we talk about quadratic formula and when we talk about completing the square. That's where we have square roots in our quadratic formula. Completing the square, we're taking square roots of both sides. And so this is where we're going to see it. So for instance, these next set of examples, they've already been solved for us. We're not going to do the solving until the next video. We just want to go ahead and simplify them. So just like we did previously, the first thing that we want to do is we want to simplify the square root. Can we break it down? And so 24 can be broken down. The square root of 24 is, we can break this down to 4 and 6. 4 is a square. And so what we're going to do is we're going to bring out the square root of 4, which is a 2. We leave the 6 on the inside. We want to bring out our negative, and so it's just going to come out as an I, and then we have our 2 in the denominator. And just like we did previously, we can simplify this. All of my outside numbers are divisible by 2. And so we're going to go ahead and divide by 2. In the top, we get 2 divided by 2 is 1. 2i square root of 6 divided by 2. Well, we're just going to get rid of the 2. we are left with I square root of 6. And our denominator cancels out, and so we can go ahead and drop it. And we're done. That's all we're going to do. All right, let's look at a couple more examples of this. Example E. We want to start by trying to break down our square root. Again, I'm going to ignore the negative for now. I'm just going to work with 18. Things that multiply to 18 is 3 and 6, but neither of those is a square. And so I want to go with 9 and 2. 9 is a square. All right, we can take the square root of 9. We get that it's equal to 3. I'm going to leave my 2 inside. And again, we have that negative there. I want to pull it out as an I. And so the way that we write this is 3 plus or minus 3i square root of 2. We're going to go ahead and put this over 6. And then we want to try to simplify the fraction. We have all of our outside numbers. These are divisible by 3. And so we're going to go ahead and divide by 3. 3 divided by 3 is 1. 3 divided by 3 is 1, but we can go ahead and leave off the 1 because we still have the I square root of 2 right there. And then on the bottom, we have 6 divided by 3 is 2. Now I'm going to tell you that for me, this is a perfectly acceptable way to write this. Okay, now if you look at the book, they may write it a little bit differently. Remember that we like to separate this into a plus bi. And so what they may do is go ahead and separate this into 1/2. That is my real part of the answer. And then they may go ahead and rewrite this as square root of 2 over 2i. This is considered the proper form if we're going based on our definition. But I personally, to me this just, this requires a lot more work. And the previous answer is perfectly acceptable in my mind. Okay. All right, let's go ahead and try one more. All right, if we look at F, we want to factor 20. 20 is equal to 4 times 5. This is the ones we want to go with because 4 is a square. If we take the square root of 4, we get 2. I leave my 5 inside. And then I want to bring out my negative, and I'm going to bring it out as an I. And I'm going to put this over 6. Because not all numbers are divisible, not all of our outside numbers have a common factor as far as I'm concerned, this is a perfectly acceptable final answer. If you do want to go further, we can separate this, but again, you don't have to in my mind. We can go ahead and rewrite this as negative 5 over 6 plus or minus 2 square root of 5 over 6 I. But if you do separate it, you do have to simplify if possible. Negative 5 over 6, this does not simplify. But over here, 2 and 6 are divisible by 2. And so we can go ahead and simplify this down to square root of 5 over 3i. But as I mentioned, I am perfectly fine with this being your final answer. All right, let's go ahead and look at one last round of problems here. We are going to talk about multiplying square roots that have negatives inside. And so again, we do want to be very careful on these, because depending on how we do this, one will give us a correct answer and another one is not going to be correct. Okay, when we are working in the complex number system, the first thing that we have to do is we have to take care of the negatives. We have to pull them out. And so for both of these, I need to pull out and make this I square root of 3 times I square root of 3. We can go ahead and multiply now. If we multiply our i's together, we have I times I, that is I squared. And now that the inside numbers are not negative, now that they are positive, we can go ahead and combine them together. We get 3 times 3 is 9. Remember that I is the square root of -1, and if we square that, we get -1. And the square root of 9 is 3. And so if we simplify this down, this is equal to -3. Another way that you can look at this, but you do have to be careful with it, is we can think of this as -3 squared. And here, my square root and my square do cancel, and we are left with -3. So we do get the same thing. The main thing to keep in mind is the wrong way to do this is if we do square root of -3 squared, this becomes, if we square -3, this is 9, and square root of 9 is 3. And that is not equal to what we came up with. All right, we're done with that one. Let's come to example H. All right, again, the first thing we want to do is we want to take our negatives out. I want to rewrite this as I square root of 2 times I square root of 8. I can combine my i's. This becomes I squared. And now that my square roots are positive numbers, we can go ahead and multiply those together, and we get 16. I squared is equal to -1, and the square root of 16 is equal to 4. And so our final answer for this one is -4. All right, last one. Same thing. We want to start by pulling out our negatives. We get I square root of 5 times I square root of 3. We can combine I times I is I squared. We can combine our insides now. We get 15. And I squared is equal to -1. Square root of 15 does not simplify. And so basically what we have here is negative square root of 15. All right, last set of examples, we're going to look at our I raised to different exponents. And just remember, 4 is our magic number. So I want to know, how can we break down 23 using this 4? So here's what we're going to do, is we're going to do 23 divided by 4. This goes in 5 times. We multiply, we get 20, and we get a remainder of 3. And so what we can do is I can rewrite I to the 23 as I to the 4th. This is going to be raised to the 5th. And then we keep our I cubed. If we simplify our exponents here, we have 4 times 5 is 20, plus 3 gives me my 23. All right, so remember that we like I to the 4th. We like this number 4 here because I to the 4th is 1. And so this goes away. We don't want to leave this as I cubed. And so we're going to split this up into I squared times I. Remember that I squared is negative 1, and so what we get is negative I. When we do these, if you want, you can take the shortcut. This is all we really care about, is this remainder exponent. Notice that when we take off these groups of 4, that, it goes away because we have I to the 4th is 1, and so we don't really worry about it anymore. All right, let's come to example G. We have I to the 33. So same thing, I'm going to divide 33 by 4. 4 goes into 33 8 times. That gives me 32 with a remainder of 1. And so this is all I care about. This is equal to I to the 1, which is just I. And if you want to do it the long way, what we have here is I to the 4th raised to the 8th times I. But notice that we still get the same thing. All right, and our last one, I to the 42. We're going to divide 42 by 4. 4 goes into 42 10 times. It is not equal to 42. It is equal to 40, and we get a remainder of 2. And again, this is all we want. This is equal to I squared, and I squared equals negative 1. All right, so this takes care of basically simplifying our square roots and our patterns of i's when we have larger exponents. There are other things that we can do with complex numbers, and that's what we're going to look at now. All right, the last thing that we're going to do is we're going to do some arithmetic operations with complex numbers. And so this is just to show you that a lot of the rules that we were talking about in all of our previous classes or previous sections, they still apply. And so when we talk about arithmetic operations, we're going to be talking about adding, subtracting, multiplying, and we're not going to look at dividing. So basically what we want to do when we are talking about arithmetic operations is we want to treat I like a variable for most of the problem. For instance, when we are adding complex numbers, what we're going to do is we're going to combine the real numbers together, and then we want to combine the imaginary terms together. And so just like if it was a variable, we want to combine the constants, we want to combine the variables. If we are subtracting, we do need to remember to distribute the negative. And then again, we're going to combine, I'm just going to call these like terms in quotations, because they are all technically numbers. But we want to combine the reals together, we want to combine the imaginaries together. The only thing that we need to be careful about that might be a little bit different is when we are multiplying. When we are multiplying, we are going to still use FOIL. But before we get down to our combining like terms, we want to change any I squareds to negative ones. Remember, I squared equals negative 1. And as soon as we do that, then it's now a real number, and we'll combine it with our real numbers. All right, so let's go ahead and look at some examples of this. All right, we're going to start with just some addings and subtractings. Because this first problem is an addition, remember that our parentheses really have no computational meaning to them. We don't have to do anything special. If you want, you can go ahead and just get rid of the parentheses. The only reason that they are here is to indicate that this is our first complex number and this is our second complex number. From here, we want to combine like terms, again in quotations. And so when we look at this, we can combine our constants or our real numbers. We get negative 2 plus 4 is 2. And then we want to combine our I terms, our imaginary terms, and we get negative 3i. Again, remember, imaginary numbers or complex numbers, we do want to write this as a plus bi. We like the real part in front and the imaginary part in the back. All right, and we are done. This is considered simplified. All right, let's come over to B and C. These ones we are going to have to do a little bit more work, and it's only because we do have a subtraction here. And so just like when we talked about simplifying expressions, the first thing that we wanted to do was get rid of the parentheses. Our first set of parentheses has no special meaning, but our second set, we do need to distribute the negative, and we get minus 8 minus 3i. From here, we can go ahead and combine our like terms. We get 5 and negative 8. And so the real number component is going to be negative 3. And then we can combine negative 7i and negative 3i. And our imaginary component is going to be negative 10i. And we're done. All right, for example C, again, we do have a subtraction here, so we do need to distribute. Remember that real numbers are technically complex numbers, and so this first number, 4, is technically a complex number. All right, when we distribute, we get negative 7, we get minus 2i, and then we want to combine. So I can combine my 4 and my negative 7. We get negative 3, and then the minus 2i has nothing to combine with, so we will just bring it down. All right, so that takes care of our adding and our subtracting. The next thing that we want to look at is multiplying. And so with multiplying, again, remember that we can essentially think of this as binomial times binomial. And so we do want to start by foiling. So if we FOIL, we get our firsts is negative times 7 is negative 35. Our outsides, we get negative times negative becomes positive 45i. Our insides, we get I times 7 is 7i. And our lasts, we get minus 9i squared. For this last term, remember I squared is equal to negative 1. And if we multiply that by the negative 9, we are going to get plus 9. We can bring down the rest of this. And then we can go ahead and combine our like terms. And so now, not only do we combine the middles, which we should get 52i, we can also combine our firsts and our lasts, and we are going to get negative 26. So our final answer is going to be negative 26 plus 52i. All right, let's look at a couple more. If we come to E, we're going to start by foiling. So if we FOIL, we get 3 times 3 is 9. For our outsides, we get plus 6i. Our insides, we get minus 6i. And for our lasts, we get minus 4i squared. Again, I want to replace my I squared with negative 1. Here we also get that our 6i's cancel. This is essentially difference of squares is kind of what we're playing around with. And if you remember in difference of squares, there's no middle term. And so what we end up with here is 9 plus 4. 13. Now, I'm not going to worry you guys about terminology, but just so you know, we do have a special name for something like this. We call binomials that are exactly the same except for the signs. We call them conjugates. Here, because we are talking about complex numbers, we actually refer to this as something called complex conjugates. And so complex conjugates, what we have is everything is exactly the same in our factors, except for we do have different signs. We like complex conjugates only because when we multiply complex conjugates, we do get a real number back. It's not gonna have an imaginary component anymore. All right, let's look at one more. All right, if we look at F, you would think that this one would probably be, we're squaring a complex number, so you would think that this one would turn out to be real, and it actually does not. So if we go ahead and start by expanding this out, I'm going to rewrite this as 1 minus 3i times 1 minus 3i, and if we FOIL, we get 1. Outsides, we get minus 3i. Insides, we also get minus 3i. And last, we get plus 9i squared. I'm going to replace my I squared with -1. We get 1 minus 3i minus 3i. This now becomes a minus 9. And now when I combine, i's become -6i. And my constants, or my real terms, become -8. And so this is going to be -8 minus 6i. All right, take a few minutes and try the last examples and see what you come up with. All right, if we look at the first one, it is addition, so I don't have to do anything. We can go ahead and just combine, and so we get -3 plus 5 is 2. And we get 4i plus -i is plus 3i. All right, for h, we want to distribute to clear the parentheses. We're going to bring down our -7i. We get -6, and then we get plus 5i. Remember that we do want to write this real then imaginary, so I'm going to start with my -6. And then I'm going to combine my I terms, and I get -2i. And the last ones, if we FOIL this, we get 9 minus 6i minus 6i plus 4i squared when we FOIL. We replace I squared with -1. We get 9 minus 6i minus 6i minus 4. And then when we combine, we get 9 minus 4 is 5. And our -6i's combine to give us -12i. All right, last one. We want to go ahead and not FOIL, but this is going to be a distribute. And so when we distribute, we get -6i. We get -8i squared. I want to replace my I squared with -1. And so this becomes -6i plus 8. But remember that we do want our notation as a plus bi, so I'm going to flip this around. I'm going to rewrite this as 8 minus 6. All right, that finishes up this section. In the next section, so here we've been given complex numbers and we've been working with them. In the next section, we're going to go ahead and revisit quadratic formula and completing the square in order to find solutions to equations in the complex number system. So we will go ahead and look at that next, and I will see you again soon.